This is the Building Automation Monthly Podcast with Phil Zito, episode 141. Hey folks, Phil Zito here, and welcome to episode 141 of the Building Automation Monthly Podcast. If this is your first time here, welcome. If you are a regular listener to the podcast, welcome back. So in this episode, we're going to be talking through analytics and how analytics can be used by building automation contractors and system integrators to grow their business and add some new revenue streams to their business, while also providing some really good value to their customers. In order for us to go and make sure that we have an effective podcast episode, we first need to make sure we're on the same page when it comes to terms. So I'm going to go through a couple common terms right now that you've maybe heard in the past, maybe haven't, and we're going to discuss these and make sure we're all on the same page. The first term is algorithms. Algorithms are nothing more than equations. If you think back to school where you maybe had to do something like x plus 2 equals 5, where x was 3, and so 3 plus 2 equals 5, that was an algorithm. An algorithm is simply a way of calculating some value. And since ultimately all of the information we work with in a building automation system is data, we are able to go and write algorithms that analyze that data, looking for patterns or abnormalities and learning how the data should be performing. One of the ways that we learn how the data should be performing and we identify abnormalities is through the process of FDDs, also known as fault detection diagnostics. So these are a subset of algorithms that allow you to detect faults. Now, faults are not failures. Faults are just deviations from the norm. So deviations from the norm may be things where you have simultaneous heating and cooling. Deviations from the norm may be that your stroke time on your dampers or actuators is taking increasingly long to get the same result. So for example, whereas with the previous outdoor air temperature, you used to open a valve to 50%, you would get, a 49 degree discharge off your coil. Now you're getting 52 with the same input variables in chilled water temp as well as outdoor temp and same damper position. An algorithm is going to notice this difference. This fault detection algorithm specifically is going to notice the difference, and it is then going to provide an alert, which is different than an alarm. And it's really important that we annotate that, because alerts and alarms, when I was selling analytics and designing analytics systems back in 2012, so many folks were caught up with the difference between an alert, an alarm, a fault, and they just couldn't wrap their minds around why they needed analytics when they had a building automation system that was doing alarming, which that's a whole nother topic on alarm fatigue and why alarms are not necessarily the best way to actually monitor your system. But suffice to say, FDDs, fault detection diagnostic algorithms, are one of the better ways to really understand when system performance is not optimal. Speaking of analytics, there's kind of two ways you can deliver analytics. There's actually several ways, but the two main ways are either through on-prem or off-prem solutions. On-prem solutions tend to be software that you either purchase with the building automation system or it's independent of the building automation system and it's a standalone software package, but you own it. And then there's these off-prem, meaning they are not physically, the software is not physically located on the site. It may be located in a data center or in the cloud. And this is typically delivered through a software as a service model. Now you have infrastructure as a service, software as a service, platform as a service. You also have managed analytics as a service. You have so many freaking services. It's like everyone and their mom's creating a service these days. But the most common three services are software as a service, platform as a service, and infrastructure as a service. You as a building automation practitioner or owner operator or design engineer really need to focus in on software as a service. And basically the model here is that you pay a perpetual cost, sometimes in a agreed 12-month term, sometimes on a monthly basis, but you pay a cost, essentially an operational cost, and you don't own the software. But in return for providing that cost, you're given things like Software is hosted in the cloud, so it's always up to date. They're adding new algorithms and adding new rule sets. The list goes on and on. The fourth term I want to discuss is data normalization. And this is typically when we hear that analytics are expensive, when we hear that analytics are difficult, it's usually a data normalization problem. There is the issue of being able to actually process the data that's coming from analytics and make decisions. That is an issue in itself. However, the bigger issue tends to be data normalization. And this is basically making sure that all the data has a common frame of reference. This is why this whole tagging thing is such a big deal, because it's supposed to, at least in theory, provide data normalization. What does this look like? Well, for example, if I were talking about a car and I called something a door and you called it an opener or a hatch, while we may, if we're standing right there looking at the same thing, be able to figure out what we mean by those two different terms. The problem is that building automation systems, analytic systems as a whole, they function. I was trying to say a word there. They function based on algorithms, and algorithms accept a specific data type. And if we don't have the data normalized, if we're not using the same quote unquote data terms, we're not calling the data the same thing, then the algorithm doesn't know how to process the data. And so for existing sites, this is why building automation system analytics can be expensive, because of the act of not only adding the data points you need for the algorithms, but also doing data normalization. Now, on the flip side, with new construction and new builds, you also tend to run into data normalization because most folks don't have a building automation standard. If I data about our most sought after consulting service that we provide, it's helping folks write building automation standards. And one of the things they really want to focus in on is getting their data, quote unquote, analytics ready or future ready. And that's something that you see included in very few specs. Naming standards, data type standards, tagging, any of those parameters and functionalities that could make data normalization easy, you typically don't see those specified in a project. So with that common terminology now discussed, and now we have that kind of base platform for us to work off of, let's really dive into what are analytics, common analytic types, how we can use analytics as part of a business service, the different types of analytics we can use, when we should use each type, and then how to actually build out a analytics service for our customers. So this is going to be a pretty beefy episode. It's most likely going to go over our typical 30-minute time frame that I try to keep these episodes in, but this is a topic I seem to get asked every single time I am meeting folks in person or talking to folks on the phone. It almost never fails that I'm asked, hey, what about analytics? What do you think about analytics? What can we do with analytics? What analytics should we use? And the list goes on and on. So what are analytics? Analytics could be as simple as trends. They could be as complicated as a self-tuning system that analyzes itself and changes process variables or changes set points to control process variables. Set points being the value that a process variable is trying to achieve. And that's one more term we should really get on the same page about: process variables. If you've listened to this podcast for any amount of time, you know what it is, but for those of you who are new, a process variable is simply the value that is controlled by some sort of process utilizing a set point. So essentially, if you have zone temperature and you have a zone temperature set point and you control a damper on a VAV box in order to control that zone temperature, then zone temperature would be your process variable, zone temperature set point would be your set point, and then your control process would be opening and shutting that damper actuator. So as I mentioned, that could be self-tuning systems, analytics can be, but they're usually somewhere in between. Now, what are the common capabilities we tend to get from analytics, and why do they matter? Well, it's no mystery that as far as we can see, there is going to be a shortage for the foreseeable next decade of building automation professionals who can both operate buildings as well as who can, I cannot speak this episode, who are going to be able to install building automation systems. So we're going to have a shortage on operators. We're going to have a shortage on installers. We're going to have a shortage on service personnel. How are we going to deal with this? We're going to use technology to help us get to the answer faster when it comes to failures, when it comes to commissioning systems, when it comes to retro commissioning systems, et cetera, et cetera. So common analytics capabilities that we look for are alerting. Now, alerting is different than alarming. Alarming tends to exist based on static thresholds that once achieved or violated, you then trigger an alarm. If you have a fan running and the filter status alarm triggers, then you have an alarm. If you go above a specific zone temperature, then you have an alarm. An alert is an indicator of some potential form of failure. Now, these are typically assisted by fault diagnostic algorithms, but not necessarily. So those fault detection diagnostic algorithms can produce alerts, but you can also have hard alerts that exist based on static thresholds, very similar to alarming, but they actually, I would argue in that case, they are alarms. Really what we're talking about when it comes to alerts are the outputs of these fault detection algorithms that are saying, hey, you know what? This system used to take 5 minutes to reach occupancy variables at 6 a.m. in the morning, but now to reach the occupancy temperature, it is taking 10 minutes, and the outdoor air is the same, and the BTU load's the same, et cetera, et cetera. Because you can do some really cool, fancy stuff. You can actually add BTU loads for things like regression, which basically is you're offsetting analytics with a BTU load, like how many people are in the building, because people put off BTUs, people put off heat. And so you can actually look at the thermal load in a building dynamically if you're sitting there and watching how many people badge in and out of the building. Now, if that just completely blew your mind, like you're like, what the hell is this guy talking about? What I was saying essentially is that while you can have these fault detection diagnostic algorithms, and they can just simply look at system performance, they can also take in external variables like how many people are in the building, which location is the sun at, what percentage is it at, where are shade positions, et cetera, in order to determine the environmental effects on system performance. In addition to this, from these fault detection diagnostics, it can look at operational performance and how you operate the building and make operational suggestions. Now, this is more on the advanced end. Typically, what you'll really see is some form of alerting and fault diagnostic and detection, and then a more advanced reporting capability that analyzes past performance. So that's really what you have is you have past performance analysis that is through regression and pattern recognition, et cetera. And then you have fault detection diagnostics, which are more real-time, providing real-time alerting, indicating that something may fail. And these operational suggestions, they sometimes can come from a analytics service, as well as energy and staging suggestions, as well as set point resets. So you can see this in some of the more advanced analytics solutions that are out there. Now, it's important to determine where the analytics are going as far as where they're being installed. Are you installing them on a new building or an existing building? Now, this looks quite different depending on what kind of building you're installing analytics on. You see, on new buildings, our primary concern is making sure we get the right points mapped in and we get the right data nomenclature up front. We get our data normalized up front. We collect the right amount of data at the right intervals, and we pull it into our analytics solution. Existing buildings are a little less forgiving and more expensive in that we typically have communication buses that don't support rapid data collection. We tend to have controllers that will die if we start to stress them too much. We tend to not have the point density we need, meaning we don't have enough data samples. So for example, if you're trying to look at a dynamic performance of a specific floor for temperature and humidity, but you don't have the right sensors in the right spots, you can't do that without additional cost. So it's definitely easier to do in new buildings, but it can be done in existing buildings. The more important thing to look at when it comes to evaluating a building automation system, or rather evaluating a building if it is a fit for analytics, is both the usage of the building, what kind of analytics you're going to implement, and the ROI that those analytics can provide. And that's something we're going to dive much deeper into later in this episode. So as I mentioned, there's several different types of analytics, and these aren't the capabilities, these are rather the types of analytics. So you have trending and reporting. Those are kind of called the poor man's analytics, or I like to call them the original analytics. I still am a firm believer that most buildings are not properly utilizing their trending and reporting. And because of that, you are really you're throwing money down the drain. You paid for these capabilities, but you're not properly implementing them. This goes back to folks not having a building automation standard, which, I mean, before you ever get analytics, make sure your trending and reporting is good, and make sure you have a building automation standard, because all the data in the world is going to be useless if you aren't collecting it at the proper intervals. From here, we move into embedded analytics. This is kind of a newer thing, but we're seeing this in a lot of edge controllers. We're seeing this in a lot of supervisory solutions where the analytics are actually embedded in the devices themselves. Some of them will provide data back to the end user. Others will go and just make adjustments to the programs themselves. The more common of the embedded analytics are the ones that report back to the end user. Then we move into a dedicated analytics software. This would be like your SkySpark solution, where it's an analytics software suite that you purchase, and you purchase a certain amount of points. And then based on that, you can go and execute certain algorithms and certain analysis that will allow you to analyze your building performance. And then from there, we move into software as a service, and we move into managed software as a service. Managed software as a service is basically software as a service, except for you've got someone monitoring it and managing the results of the feedback from the analytics solution, and then providing either actions or suggestions based on that. So that's a really important thing to take note of for those of you who own or operate a building automation contractor or system integrator and are looking to kind of expand your line of business. Managed SaaS is a way, it's actually a low risk way, in my opinion, that you can go and immediately provide more value to your customers and create a renewable revenue stream. So how do you decide which building automation analytics server or software to use? Well, first off, you need to look at, is this a new or an existing building? Because the reality is, on a new building, you can, depending on where you are in the specification and construction document timeline, you can go and actually influence point density and system design and naming and et cetera, et cetera. However, if you're with an existing building, you're often within the limitations of that existing building and the limitations of that customer's wallet to change that existing building. It's a lot easier to influence a new specification and new build than it is to go and actually find capital funding for an existing building, because you'll get the argument of, hey, we already have a facilities group. That's their job. Why do we need to go and add all this data, et cetera, et cetera? And which brings us to really our second point that we need to think about, which is a clear ROI tied to uptime. You know, a commercial office building that's 2 stories that's owned by folks who just want to own the property to lease it out and they don't really care about how the property performs is completely different than a hospital with 24 operating rooms. There's a clear ROI tied to the uptime of that operating room. There's not as clear an ROI tied to the performance of that building, and the tolerance level of an operating room as far as deviation from set point of humidity, airflow, and temperature is much, much less. They are much less tolerant of deviation than maybe a tenant sitting in a commercial office building. So understanding that ROI, understanding the acceptable levels of deviation from your controlled values, your temperature, humidity, etc., is incredibly important. So you've got this newer existing building, knowing that existing buildings are going to be more expensive. You want to make sure that this system, this building, has a clear ROI tied to it, you have enough assets for this to actually be worth it. Meaning if you have one air handler and 10 VAV boxes and that's all you're ever going to have, that is probably not feasible to implement an analytics solution. However, if you have 24 or 100 air handlers and thousands of VAV boxes across a campus filled with buildings, then it may actually be worth it to go and analyze these assets. And then you have to have sensitivity to data flow, both from an infrastructure perspective, especially with existing buildings. I mean, you can real quickly overwhelm an existing building network. That's why IP controls are so valuable, because they utilize high bandwidth communication methods in lieu of our serial networks, which I can't think of any way to say that a serial network is comparable to an IP network, whether it's wireless, point-to-point, or Ethernet. There's just no way an MSTP trunk is ever going to compare to an IP network. It just can't. And so the sensitivity to data flow, especially with existing buildings and especially with existing building systems, is something we really need to be careful with, especially if we really want a highly dense building and we want very rapid data collection. Maybe we're working with a data center, maybe we're working with a hospital, we're working with some building that we really want fast reaction time from our analytics solution, then we really have to be careful with our data flow. And a lot of folks don't think that through. Which brings us to our next question. Now, as we start to think through, okay, we understand the different types of analytics. We understand the benefits of analytics. We understand the common terminology. We understand the different reasons why we would or wouldn't use them. And we understand the constraints in deciding which form of analytics we are going to use. Now we have to say to ourselves, do we want to provide a solution, an embedded analytics or trending and reporting or dedicated analytics software? Or do we want to provide some form of service, either in the form of a SaaS or a managed SaaS? How do we determine that? Well, solutions are typically fire and forget. They rely on the customer, and they're typically for fairly static systems. So if you've got a 8-story commercial office building, maybe you've got a couple of these buildings, and the customer is got in-house maintenance, then you could most likely use a analytics solution, purchase an off-the-shelf solution for the customer, set it up, and then that customer could just implement it as part of their maintenance process. Now, if you have a large campus, or you have a large corporate office park, or you have a large hospital, and maybe they don't have the capabilities to actually look at this analytics software, figure out what it means. Because in order to use analytics software, it's not just, ooh, look, there's simultaneous heating and cooling. I mean, yeah, that's the obvious one. Folks will tend to point to, two kind of, whenever you get a demonstration from analytics providers and they come to you and they show you their analytics solution, they're going to typically show you one of 4 analytics case studies. They're going to show you simultaneous heating and cooling because, oh my gosh, if you're heating and cooling at the same time, you're going to waste BTUs. Or they're going to show you an outdoor air damper that's open and leaking through. Oh my goodness, we're getting cold or hot air in the building. Or they're going to show you a door's been left open. Oh my gosh, who would have known? Door all night. Or they're going to show you, oh look, these systems are running when they shouldn't be running. Okay, yeah, I get it. But the reality is all of those things put aside, those are operational problems. And if the customer does not have good operational practices, you can point those things out till you're blue in the face, but they're not going to do anything about them because of the fact that the operational failures and the just lack of situational awareness that led to those issues happening in the first place is also going to lead to them not using the analytics solution. Let's not lie to ourselves and say, oh my goodness, look, there's all these analytics alerts. I'm going to magically change all of my habits that I've ever done, and now I'm going to go out and fix everything. I mean, the reality is that is not going to happen. I mean, it may happen for a month or two, but it's just experience has shown me time and time and time and time again, people are creatures of habit. They're going to go back to their level of comfort. This is where the service comes in. And this is where I think a lot of building automation contractors and system integrators really need to evaluate kind of how they're structured. They need to evaluate the skill set and ability to support this model. And I really think it's something that could be immensely valuable to our industry. Because let's be honest, I've met very few companies that can simply sit there and grow by double digits simply chasing plan and spec work. The reality is, if you want to have high profit work, you need to be connected to your customer. And in these days, there's just so many different solutions out in the market. It used to be where you could get your platform flat spec'd and you may have a couple competitors, but now you have dozens, if not, 30 potential competitors in the large metropolitan areas for different plan and spec work. So sitting there going after that work is becoming increasingly competitive. Being able to be connected with your owner and being able to provide, both not only day zero, but also day one and beyond support is an invaluable and very profitable position to be in. So it's really important that you take this seriously. So how do you go about implementing an analytics service? Well, the first step is to identify your target vertical market. So this is incredibly important. If you take anything from this podcast episode, it is, if you're going to do an analytics solution and an analytics service, you need to pick a vertical market that you are going to dominate. Maybe that's healthcare, maybe that's education, maybe that is data centers, etc. But the reason you want to do this is because of step 2. You need to develop the domain expertise. In order for you to properly analyze analytics, even if you're not the one responding to it, maybe you're just in an advisory role to your customer, in order for you to make sure that the analytics are actually properly implemented, you can't plug in analytics that are designed for a commercial office building and expect them to provide adequate results for a hospital or for an airport or for an educational building. The reality is that there is a certain amount of domain, meaning specialized knowledge, for that type of building. The way you condition a space in a hospital is different than a data center, is different than a K through 12 environment. So you need to really make sure that you develop that domain expertise. The best way to do this is to pick a vertical that you're already serving with your installer service work, because you're most likely going to already understand how it works. Now, from here, you move on to step 3, where you decide how much support you want to provide. Are you going to be turnkey? Are they going to simply pay you a certain amount each month, and you're going to do everything from analyzing the system all the way to executing rolling trucks and servicing their equipment? Or are you simply going to provide a solution and then say, hey, here's your solution, you're done, and call it a day? You need to figure out what level of support you want to provide. And then once you've done that, you need to establish the systems and processes for that level of support. Does that mean you have to have a call center? Does that mean you have to go and stand up a server on AWS to run the analytics software? Does that mean you need to get someone with IT security background? That way they can work with the customer's IT staff to actually pull data out of their systems. From here, you go and you implement in your first client. And this is where feedback loops that we talked about in episode 140 become so critical, because in your first implementation with your first client, it's not that you're trying to be the most profitable, you're trying to be the most efficient and proficient, because what you're trying to do here is identify waste. Where are your processes and systems inadequate? Where are you wasting time responding? Where are you doing duplication of effort? And as you analyze that, you remove that waste from your processes and your systems, and you provide adjustments. And once you've done that and you become fairly confident in your ability to serve that domain, that vertical market, then you make leaps to other vertical markets that are similar. This is lateral leaps instead of vertical leaps. So you're not going from healthcare to transportation. You may be going from hospitals to medical office buildings. Ideally, I would say you go from medical office buildings to hospitals, something like that. From K through 12 to higher education, from corporate customers with on-site data centers to actual dedicated data centers. You see, you're taking a low-risk domain and then you're moving towards more of a high-risk domain. And the higher-risk domains are naturally going to be higher margin work because the level of ROI dealing with somewhere where if it goes down, there's millions of dollars of damages, that justifies a higher cost for that service. So I hope this has helped you to better understand analytics, to think about where you can apply analytics within your business, even if you're not someone who owns or operates a system integrator or a contractor, even if you're someone who just simply operates a building or you're a design engineer. This episode should give you an idea both how to write your specifications as well as from an owner perspective what to look for in an analytics solution, especially if you're going to execute one in-house. Really focus in on these last couple steps I gave you. They're going to be very valuable for you to make sure that you properly implement your analytics service. So with that being said, thanks a ton for being here. I can't wait to talk to you all in next week's episode. In next week's episode, we are going to be discussing how to sell the value of a BAS. So many folks think that all components of the BAS are the same, and it's, how do I provide value with my building automation system? What can I do to provide value to customers? As a customer, what can I do to demand value from my contractors? We're going to discuss all of this in next week's episode. So all of the notes and everything I discussed today are available at buildingautomationmonthly.com/141. Once again, that's buildingautomationmonthly.com/141. I'll provide some links to some resources where you can dig a little deeper into the topic of analytics. And with that being said, thanks so much for being here. Can't wait to talk to you again next week in episode 142 when we discuss how to sell the value of a building automation system. Thanks a ton. Take care.